item 224. The actual session will have that plus leftover from lecture number 3. That's 3. That is the leftover from 2 and 3, but lecture number 4 is not very long. It will allow us to cover the leftover. Right? Okay. So I'm going to start with setting up lecture number 4. That's not going to take a long time. And then we're going to do stuff left out. That's 3. Then at the end we're going to do plus. Okay. Suppose there are 2 demands. 2 consumers. Okay. That is 1. That's the second. That is the first one demand. That is the second one demand. So suppose there are 2 in consumers only, and they basically will give you the market. How do you go from individual demands to market demand? That's the question. How you stack up the individual demand to get the market demand? Right? Assuming you have 2 consumers. Right? Okay. You may say that's not very hard. You just calculate QA, QB. Calculate the quantity each buys, and a market demand should be what all together buys, so sum up. Technically, horizontal sum up the curves. Add the quantities, not the prices. So you may say, we just take the individual demands, sum them up horizontally, meaning add the quantities to get the market demand. In this case, it should look like this. Is that true? So you may say the market demand is just horizontal demand summed up. That's exactly what we did there. We took horizontal demand, summed them up. We took individual demand, summed them up. Is that the market demand? It would be. If these 2 would have left the market at the same time. But they don't. The highest price this guy wants to pay is how much? That is 50. This guy highest price is 100. They don't have the same reservation price. That will be demand if both are in the market. But they won't be in the market for all prices. This guy leaves earlier. So this becomes the market demand when both are in the market, i.e. when the price is lower than 50. Right, so that is market demand. When the price is low enough for both to be in the market. Right? Make sense? But when the price goes up, then who leaves the market? A will leave the market, B is still there. That will be the market demand then. The market demand then turns becomes B, which is this one. So unless you have all consumers having the same reservation price, which is rare, the market demand becomes king. If the higher the price, the more people leave the market. Right? The lower the price, the more people join in. Right? So in this case, the market demand is king. Once, because you have 2 people with 2 reservation prices. If you have like 100 people with 100 reservation prices, you're going to end up with 99 kings. Right? Okay. If you want to graph the market demand, should look like this. That's the market demand. That's the price. What's the highest price anyone wants to pay in that market? 100. What's the highest quantity sold in this market? How much? The highest quantity is when the price is 0. That is 100. 150. So that's the other end of the demand. But the demand is kinked at 50. That is when the two lines, two markets, well, two segments of market demand cross each other. The demand is kinked at 50. 50 should be in both of them. If you put 50 in this, you get 50. If you put 50 in that, you get 50 as well. That is the intersection of our kink market demand. This is our market demand. All right? If you ignore the kink, you're basically assuming the market demand is this one, which is not correct. That assumes when the price goes above 50, this guy buys a negative number. That's what it assumes, right? If you just add them up, ignore the kink, that assumes when the price crosses 50, this guy will still be in the market buying a negative number, which is impossible, right? So you should kink. When the price drops, the demand becomes flatter, right? This is flatter than this one. See, the demand is steeper, but you're graphing the inverse of it. More joining, the more steeper the demand becomes, but you're actually graphing the inverse demand. So the actual demand is steeper, that's towards the slope. The inverse demand becomes flatter. Right? If you have like 100 consumers with 100 different reservation prices, the demand looks very much like convex. Because the lower the price, more people join in, the flatter demand becomes. That's the reason people use Cobb-Douglas CS, because they all give you basically convex demand, which is sort of appropriate at the aggregate level. Yeah?
Nothing.
Yeah. So kink demand, technically, at the market level, with many consumers, give you convex demand. But in this case, we have just two people, so obviously you're not going to see convexity. Okay? Okay. Anyway, suppose the price is 25. How much the first consumer buys? 25. Right? How much the second consumer buys? How much? 50. How much the market buys? Well, you should put 25 where? Here or there? There. What do you got? 100, right? You get 100? If the price is 25, you should put 25 there. You get 100? Is that? That is, this should be 75. You gave me the wrong number. That's 75. Pastor Reina hesitated. If this is 25, that's 25. If this is 25, that is 75. So if you basically have the price 25, one consumer buys 25, the other one buys 75, and the market buys 100. Make sense? Okay. Anyway, consumer number one pays 25, buys 25. That's the cost of purchase for him. That's how much he pays. Consumer number two pays 25, buys 75. That's the cost for him. Make sense? But consumer number one is willing to pay all the way up to this. So consumer number one collects a benefit from paying 25 because they're willing to pay all the way to the demand. Alright, that's the highest price they want to pay. So consumer number one is left with this, what do you call it? Surplus. And consumer number two is left with this surplus. The surplus becomes how much you pay, subtracted from how much you would have liked to pay at max. The demand tells you how much you would like to pay. Anything between that and what you pay, that is the surplus. So the surplus becomes the pink area. Make sense? So anytime you buy anything, you collect some surplus. Unless you want to pay exactly that number, which is very rare, right? Say, if you register at U of T on an international tuition, right, you collect a surplus. Although you may say, this is so expensive, it's like 70,000. It's not. If it was, you would not have registered. You would have liked to pay more. Make sense? You collect a surplus. The only one who doesn't collect surplus is you don't buy. Or that marginal player. That's sort of the one who actually wants to pay 70,000 and pay exactly 70,000. It's rare, right? Most people who actually buy, they would like to pay more. Right? As a result, they collect benefit, which we call surplus. So in this case, the surplus for the first one is how much? 25 multiplied by 25 divided by 2. How much is that? For the second one is 75 divided by 2. What's the surplus for the first consumer? Too large. 25 divided by 2. This multiplied by this divided by 2. And then this multiplied by this divided by 2. What's the first one? 25 multiplied by 25 divided by 2. 300? Gotta be somewhere in 300. 312? Point? 5. What about the second one? 75. What is 75 to? How much? 281?
2.5.
One more time. 2?
Sorry, it is 2081 2.5.
2081. Point? Rounded. You round it with it. 2081? Point? 2008. Point 1? I wrote 2008.
No, 2,812.5.
I'm not the problem, you know that, right? 2,812?
Yeah, 25.
Okay. 2025. 0.5. Again, I'm not the problem. Anyway. Okay. What's the market surplus? On the graph, the market surplus must be this one. Calculate that area. Try to calculate it. They're all straight lines. So it's doable. You can actually split it in 3 parts and calculate these 3 areas. Right? You will get this plus this. The market surplus is nothing but individual surplus summed up. Right? You can get it from individual, you can get it from the market, they're all the same. So the market surplus in this case is 312 point 5 plus 2,812.5. Right? So try to get that area, you will get that number, right? Make sense? But this is more intuitive. Individual give you the market, so see what the individual do, you'll figure out what the market does. Right? Anyway, what is in words, based on what you learned in Area 2, what does actually this number mean? 312.5. What's the denomination of this number? What is 312.5? I know it's a surplus. That's what you learned in Area 2. What does actually mean? What does? Yeah.
How much extra utility or satisfaction the consumer
It's not utility at all. That's $1.
satisfaction?
This is how much revenue you keep, because the market cannot charge you what you want to pay. That's what it is. So you basically left out with $312.5 in revenue because the market cannot charge you what you would like to pay. They cannot discriminate. You don't know who you are, right? They don't know who you are. They cannot really figure out how much you want to pay. They charge you the same price as everyone else. And in the process, they collect surplus, which is revenue, right? It's not utility. The satisfaction there is dollar denominated, right? It's basically dollar. The company could have got it from you, but they can't because they don't know who you are. If you go to Tim Horton, try to buy a coffee in the morning, how much you like to pay? You might say $50, but you pay $2. You collect $48 in surplus. It's a dollar number, right? Make sense? The dollar gives you satisfaction at the end. But the surplus, when you quote it, it's just a dollar number. Okay. Anyway. Okay, if you think about it, this area is P multiplied, that's a revenue. PQ, revenue. It's a dollar denominated revenue. Make sense? Okay. Anyway. Okay, that's sort of a setup. I did a bit of this, but I'm gonna do more when I do the questions. I wanna go back to lecture number 3. We left out from it the last question. We left out this one, which will show up a version of it on the quiz, so I want to do it. You have what we call perfect substitute. We want to find a demand for it. And then we want to find optimal bundle based on the numbers given. Make sense? We want to find the demand first. Demand doesn't require any number. So I'm going to just look at, not this one. Just look at the utility. And find a demand. Then I'm going to apply the numbers. That will give me 1 point on the demand, which we call optimal bundle. Fine? Okay. How do you find the demand for perfect substitute? We did class number 1, Cobb-Douglas CS. We did class number 2, perfect complement. We haven't done perfect substitute. We haven't done quasi-linear. That's left out. So I'll try them here. We start with perfect substitute, and we're going to end with quasi-linear, both from last lecture. Okay. How do you solve for this one? How do you find the demand? Well, find the MRS first. What's the MRS in this case? MUX, MUI. That is 2, 6. Right? That is marginal utility. That's the MRS. Marginal rate of substitution. Right? You compare it with relative price, then decide. Make sense? You check MRS. That's the willingness to pay. That's how much you're supposed to pay. Compare them, decide. Now, this can be more. If it's more, what do you do? This is how much you like X versus Y. This is how much it costs you to buy X. So what do you do then? You like X more than how much it costs you to buy it. So you keep buying it. More and more of it. Until you can't buy any more. That's the corner solution. So you spend all your money on X, that's the maximum you can buy, and you spend no money on Y. That's one side of the corner solution. If it's less though, it's the other way around. If you don't like X, you keep buying less and less of it until you buy 0. And then you only spend money on Y. So demand for X becomes kinked. You either spend all your money on it, that assume MRS is, in this case 1/3, 1/3, is more than relative price. Then you spend no money on X if it's less. It's kinked, right? Not this. It's not this, it depends on the case. It can be this, or it can be this. That's a kink. It's either this or that. Demand for Y is the other way around. 0 here, py. So both demands for x and y are kinked. See, it's too close there, so let me write it. Demand for y, 0 up there, and everything will depend on y down here. Right? The demand for half a complement is kinked. Anything that gives you corner solution or potential for it will give you kinked demand. That's the easiest one. The perfect substitute always give you corner solution. So the demand for it is always kinked. Right? It's not this one, it's not this one, it depends on the case, can be this or that. Okay, so now let's find part B. Basically find one point on the demand based on the numbers given. Okay. The question says the income is 120. The income is 120. Price of X is 1. Price of Y is 2. What's the optimal bundle now? Where are you on the kinked demand? Are you there or there? MRS is 1 over 3. Right, the price is 1 over 2. You are there. So on this part of the demand, MRS is lower than right the price. Make sense? The MRS is 1 over 3. Right, the price is 1 over 2. You're on this part of the demand. Alright? So you spend no money on X, and you spend all your money on Y. That will fetch you 60 units. Right? Make sense? That is optimal bundle. In this case, you are on the Y corner. You spend nothing on X. You don't like it as much as it costs you to buy it. And you spend all your money on Y. Right? Okay.
So Y demand is income over PY, right?
PY not because PY. Let me graph it, see what we did here. That's the bottom line. That's the bottom line, right? The slope of this one is 1 over 2. Make sense? The slope of the indifference curve is 1 over 3. Ladder. Make sense? This ladder, maximizing means going there. Let's put it there. If it's steeper, maximizing with the meant going there. So it's ladder here. You basically go all the way to this corner. That's the maximization. If it was steeper, say the average price was 1 over 6. Sorry, MRS was like say 2, you will come. Make sense? Anyway. The demand is kink, the easiest kink demand is perfect substitute. Because you know you will end up with a corner. Okay. The more difficult one, later that's quasi-linear. Well, this is the easiest one. Perfect substitute will always give you a corner solution. You will end up with kink demand always. The demand will be this or that, in this corner or that corner. Yes. Okay, that is left out from the last lecture. Just a note, test-wise, question-wise, if the question says the individual is very picky, that is perfect complement. Not picky at all, that is perfect substitute. Make sense? Perfect substitute means any point on this line are the same. They're all the same. The substitution rate is constant. If you give him this or that, or any combination of that line, they're the same. That's not picky. Right? Perfect complement means you consume them at the same rate, at the specific rate. That's very picky. Right? So if the question says picky, that's the perfect complement. If it says not picky at all, that's perfect substitute. Right? Okay, you will see that soon. I remember one time, one of the midterm, I put Vicky is very picky, and someone really get offended. I don't know if I did it on accident. It was an accident. I don't think it was intentional. I just chose the name, right? Somehow Vicky became picky, right? But it's just a joke, right? Anyway, we'll do two more from income substitution effect. We did 3 last lecture, right? I did 2, you did 1. This 2 more. We're not gonna touch it hereafter. That's good enough. The income substitution effect is the crux of demand theory. That's the reason demand looks the way it looks. Very important, right? Makes sense? So make sure you learn it, and it's important test-wise as well. It will show up. Right? Okay. Let's see. Question 1. We're on lecture number 3. Steel. That's the utility function. We want to find some income substitution effect for these prices. For that, we need the demand, because that allows us to calculate the initial bundle and terminal bundle. What's the MRS? Alpha, beta. Y, X, which is 3Y, 4X. That is MRS. In equilibrium, that should be equal to relative price. So Y should be 4 PX 3 PYX. And then you have the dotted line to work with. Take this one, plug it there, and that will give you demand. Right? So that's PXX. And that's the income. This will cancel out with this. How many of them are you going to have there? That's 1. That's 4 over 3. That will become 7 over 3. Alright? So what's the demand for X? 3I, 7 PX. Right? What's the demand for Y? There was a shortcut for it, right? IPY, what's the multiple? 4, 7. For Cobb-Douglas, the multiples will add up. Right? Again, if you don't like it, don't want to memorize it, just substitute this there. It will give you the same thing. Okay? Okay. What's the initial bundle? That is when the income is 50, the prices are 1 month. 150 divided by 7. 21? 21 pound? 4, I just rounded. What's the demand for Y? 200 divided by 7. What? 28.6? Bundle B is when the price goes to 2. So now you have 150, 14. That should be half of this one. 10 pound, 7, and Y should remain the same. Right? Make sense? A to B, which we can observe, that's the total effect of the price change, in this case, minus 10.7. Right? Okay? That's the total effect of the price change. Okay. We want to decompose it into income substitution effect. For that, we have to eliminate income effect, find point C that only has substitution effect. You call that? So we need to find point C. If we do find it, then we can say A to C is substitution effect. And then C to B becomes income effect. But we need to find point C. C, that isolate for substitution. Right? Okay, let's graph it. And with that, try to find it. What's the initial bottom line? 50-50. Terminal bottom line is 50-25. The individual is somewhere there. This is 21. Right? That's the total difficult price change. We already have those 2 points, so those are observed. We can see that 10.7 reduction. To find the substitution effect, we need to graph the initial indifference curve. As I said, don't graph it too curved. If you graph it too curved, A and C will be so close. Very hard to show it then, right? Graph it less curved, more flattish, right? That's the way you should graph it. And then try to eliminate the income effect. How do you eliminate the income effect? See, that is the no bottom line. To eliminate the income effect, you need to give the individual money. Shift this up. Give him money. Give the individual the lost purchasing power all the way to the tendency. Is it parallel? No. Make it parallel. Is it parallel? Hopefully, yes. Let me see. This is parallel to this. It looks parallel, right? Hopefully it is. But if you have a ruler, make it parallel. That eliminates the income effect. You took all the extra purchase power, you gave him all the lost purchase power. He is as happy as before, so there is no income effect left. Now you can say A to C is substitution effect, but you need to find point C. Point C give you the same satisfaction as A. That's what you can see there, right? And utility is this one. That is 2, 10.4, 21.4. That is 28.6. That's the utility of A. Must be equal to utility of C that you need to find. Alright? Make sense? Okay, that is that. Just to simplify it, we can eliminate this 2. And I need this number then. What is that number? That's not really utility of A anymore, that's half of it, because you eliminated C. What is this number? How much? I need this number. 21.4 to the power 7.75, 28.6. What do you get? 100? 285? 285. That's that one. That's 1. 2. The MRS at point C is equal to the new dotted line. This one, these two are parallel. So don't put it equal to this. That's a common, very common mistake. Not like mine. A lot of people do it. Then you're gonna get point A. Then you say, well, A and C are the same. Then you say no substitution effect, right? Then you try to fix it, and that's like 20 minutes wasted, right? Okay. So put the new one. The new one is 2 divided by 1. And the MRS is this one. 3yc 4xc equal to 2. That gives you yc, which is equal to 8xc divided by 3. And then I'm going to put this there and solve it. Then I'm going to write it this way. Right? Just then I'm going to eliminate the power by reversing it. That will isolate for pole C, which is our substitution effect. You should get it between A and B. In the world of normal goods, which is called Douglas, C is always between A and B. So you should get it between 21.4 and 10.7. What do you get? Huh? 14? Exactly? I think there's a lot of rounding there. 14.4? 14.4. Now I can plug the numbers there. That's 14.4. That's 21.4. That is minus 7. That is 10.7. That is 10.4. That's minus 3.7. I split the total effect into substitution income effect. Right? On the graph, this is SE and this is I. Right? Okay. That's number 4. Number 4. We need 4 of them. Right? The last one. Here's the last one we tried. As I said last session, 5 should help. If it doesn't, then God helps you, really. You should solve it, right? You should be able to solve it. If you don't solve it, you haven't practiced. That's the only reason, right? Make sense? There should be no margin for error. You should be able to find the numbers, graph it, right? It will show up. That's number 4. Number 5, this is actually the one that showed up on the test. I gave you A and B similar to the one that was on the quiz. If I give you A and B, don't need a demand. Because A and B is given. The reason we find the demand because we want to put the numbers in and get A, put the numbers in and get B. Make sense? This gives you the initial bundle, that's A. And terminal bundle, that is B. Alright? So you know the initial bundle. That is when the price of X is 1, price of Y is 1, and the income is 100. That's the first one. You know terminal bundle, that is 200, and Y is 50. That is when the price of X drops to 25 cents. Right? So you can easily find a total effect. That is 150. Right? That's given. You simply have to find point C to isolate for substitution effect. And then you can get the total effect as such. You just have to find point C. Right? No need for a demand. That's a waste of time. A and B is given. Why do you need a demand? Okay. So let's graph it, then try to solve it. That's the initial bottom line. Was it? Did you have 50 or 100? That is terminal bottom line. How much this should be? Anyone? That's the initial budget line, 100. What's the end of budget line for the terminal budget line? That should be 400, right? The price is 25 cents. That is 100 divided by 25 cents, that's 400. Alright? Okay. Now, this is where the individual stands. He buys 50, then 200, that is total effect. We know that. We want to decompose it into substitution income effect. I know you should graph the indifference curve, show it there, but if you graph it, then the substitution effect C might be to the right or left of this point. And the number might be the other way around. Then you have to regraph it. So let's find a number based on it, graph it. Make sense? Otherwise, the numbers and the graph may not match. Okay? Okay. So let's find it. What's the first characteristic of C? It's the same satisfaction as A. Plug A there. 10, 50.5, 50.5, 10, XC.5, YC.5. Right? I'm going to get rid of this 10 and write it this way. I solved it a bit, right? That's number one. Number two, MRS at point C is equal to the no dotted line. Slope of this one, not this one. The slope of the no dotted line is 25 cents divided by 1. Right? So the only thing really I need from the utility function is MRS. What's the MRS of that function? I don't need demand, but I need MRS. What's the MRS of that one? YX, because alpha and beta are the same. This is Y. So this gives me YC should be XC divided by 4. I take this one, plug it there, and try to solve it. That should look like this. Right? That's 1 over 2. The power will add up. I get this one, and I cross multiply to get x. Right? Okay. Now I can say A to C, this is 100 or 150? 100. 100 minus 50, that is 50, that's substitution effect. Then 200 minus 100, that is our income effect. Right? In this case, the income effect was twice substitution effect. Right? See, the reason I graphed it, because I did not know where C is. Will we bypass this one before? Now we ended up exactly there. If I graph it, then the graph may not match the numbers. Right? Okay. So let me graph it now. Let me graph it. Graph the initial indifference curve. And bring down the dotted line. That looks fine, right? That looks fine. Is it parallel? It's not. You should make it parallel. Is that parallel? It probably is, right? It is parallel. If you have a ruler, it's easier, but very hard to do it when you do it on the Microsoft. Right? That's point C. Now I can say this is substitution effect, this is income effect. Alright? We're done. How long will it take you to solve this question? If the graph is half given like the one you have in the quiz, which basically you get the graph, you get the indifference curve, you simply have to shift this one, get this one. How long will it take you to solve it? 3 minutes? 4 minutes? 5? How many? 5, 6 minutes. If this was on a midterm, how much it deserve to have? 5 points? 10 points? 20 points? How much? 5? This has 7, 8 points. I don't want one of these two. Lost a point for it. If you've done it, very familiar, right? You should do it. I can tell you 30-40%, they either miss the calculation, miss the graph, or miss the whole thing. It's not like people, for some reason, those steps aren't really remembered. Make sure you can do them, right? It will show up. Make sure you can do them. If you just put numbers there, nobody knows what is going on. How can you mark it, right? Write 1, write 2, solve it the way I solved it. So at least, if you make an error, people say, that's a calculation error, right? You're just setting it up properly, you just missed something. But if you just put numbers there, who knows what you're doing, right? Make sense? Okay, that is lecture number 3. From lecture number 3, the only thing left is quasi-linear, which I'm going to do at the end. We have left this one. I put it in red because that's not the easiest thing in the world. I'm going to do it at the end. But I want to do lecture number 4 now. We start from conceptual question. Then we go to some numerical one. Question for you. Market demand is kinked. Always, sometimes, most often. Which one? The market demand is kinked. Always, sometimes, most often.
Sometimes when it is a perfect pursuit.
No. Choose one of these 3. Always, sometimes, most often. The only way you get the market demand not kinked is if you live in an Android world where everyone buys a Tesla and everyone have the same reservation price. As long as the reservation price is not the same, which typically is not the same, you get kinked demand. The demand in the market is always kinked because people don't have the same reservation prices. But hypothetically, it can be not kinked. We live in a world where everyone have the same exit point, which is obviously right. Okay. Anyway, second. So this should be almost always. You cannot say always because there is always a chance people have the same reservation price. The second one, I haven't explained it, but should be sort of semi-obvious. Market demand for a good at a specific price will be inelastic if all consumers have an elastic demand, most consumers have an elastic demand, at least one consumer have elastic demand. If someone tells you the market demand is inelastic, what's your conclusion? Everyone in the market has an elastic demand, most have an elastic demand, or at least one have an elastic demand. Which one? What do you think the outcome is? Most, all, at least one. Well, let me give you a hint. Elasticity is an index. You don't add up an index to get the market index. You average out. So to get the market elasticity, you need to take individual elasticity and average it out, but not through a simple average, through a weighted average. The weight being the size of your purchase. If someone buys 90% of the market, they have far more weight. They have 90% of the weight on the index. Make sense? But that will give you eventually market elasticity. The market elasticity is weighted average of individual elasticities. The weight being relative size of the purchase, like each individual. Make sense? So which is the answer now? Based on that, which one is the answer? You want to make this one an absolute term less than 1. What's the condition on this one? Most? Wow. Why most? Suppose someone buys 90% of the market. Right? If his demand is elastic, that's probably good enough. You don't need others to have elastic demand. So you may end up with one consumer being inelastic. That makes the market inelastic because he has 90% of the market. Make sense? That is the reason why the answer should be almost at least 1. Because if all this is more than 1, this is going to be more than 1. So you need someone to have an elastic demand. But since you are weighting system there, you don't need most to have an elastic demand. At least 1 need to have an elastic demand because 1 might have a good chunk of the market. 1 might have 99% of the market. Then it's sufficient for him to be inelastic, for the market to be elastic. Make sense? Yeah. Anyway, so if someone tells you the market is inelastic, the only conclusion you make is someone in the market must have an elastic demand. You can't say how many. You can't say most because of the weighting system in averaging out. Alright? Make sense? The answer is at least 1. Okay, what about the next one? The next one is already answered it. You don't sum up elasticities to get the market elasticity, you average out. That is false. As a result, you sum up surplus, because surplus is not an index, it's a dollar number. You sum up a dollar, but not an index like elasticity. What about the last one? The reservation price for the market is the highest price that any consumer wants to pay for the good. True or false? Is that true or false? Is this true or false? False? If someone told you the market elasticity of demand, the market reservation price for Tim Horton is 50, what does that mean?
And it's the maximum price that
Anyone wants to pay, that's the meaning of it. Market reservation price is the highest price anyone wants to pay for the goods. That is true. Alright? If someone told you that the reservation price for new Apple 17 iPhone is 1,000, well, 10,000, it means no one wants to pay more than 10,000. That's the meaning. Alright? And Apple 17 is the ugliest phone I've seen. That's the world's ugliest phone, right? That's like so awful. Why they're advertising the orange one? Who the heck wants orange phone? Do you like orange phone? They look like a trash? I don't know, it looks awful. There are two things, well, I guess it's Apple they can sell it. If Tesla can sell that car, Apple can sell that phone. There's no problem selling it. I don't know which one is worse. Tesla car or Apple phone? Which one is worse? Think about that someone driving a Tesla having that phone in their hand. That's the ugliest thing ever, right? That's terrible, right? You have an ugly car and an ugly phone. But that car is terrible. There's nothing worse than the Tesla, what do you call it, Cybertruck? That's the world's worst truck ever. If you drive it, you should be ashamed of yourself, I think. Don't ever talk to me. You get a bad taste. It's a 140,000 car. If you pay me 140,000, I'm not going to drive that one. It looks awful, right? Anytime I see someone in it, I say, they lost their mind, right? I know. It looks like you're driving garbage bin. You're sitting garbage bin, I'm just driving it. That's the way it is. Anyway. If you have it, sell it. That's my advice. Don't ever mention it to me. Don't talk to your friends about it. Just drive it. Okay. See, the tastes are different. Some people like it. They think it's fashionable, right? Anyway. Okay. We'll do 3 numerical questions After the second one, it looks familiar because these are basically from old tests. They just change numbers, right? You can have a version of it on your, I think some people get offended. I think some people have Tesla. I was dead serious. If you have one, sell it, right? I'm not joking at all. I think it's very ugly. I think it's ugly. It reminds me of Trojan horse. You know, 2,000 years ago, you know, the Greek attacked something. It looks like the same car, right? It looked like they invented it 2,000 years ago. It's not futuristic at all, right? It's like way back in history. Anyway, we do 3 questions. You're going to see one on your quiz. Do it the way I do it. That saves you a lot of time, right? Very simple. This is basically AO2 material for the most part. Slightly twisted. A small city is populated with 200,000 consumers, split equally between Group A and Group B. Right? That's the inverse demand for Group A. That's the actual demand for it. And the reservation price is how much? What's the reservation price for the first group? If you want to find the reservation price, put Q equal to 0 in the demand. That will give you a reservation price, right? So what's the reservation price for the first group? 12. Put Q equal to 0, that's the highest price they want to pay. The second one, that is this. That is this. And the reservation price is how much? 24. 24. Right? The market demand is 100 QA plus 100 QB, which is 100. Which is 100, sum them up. Not 4, 3, yes, that's 3, 4, right? Not 4, 3. 3, 4. That is when the price is low enough for all to be in the market. If all in the market, that's the demand. Alright? When the price goes up, still lower than 24 though, who leaves the market? These are out. The second one's still in. They are the market then. And that should be the market demand, which is kinked at 12. Right? Make sense? See, these guys are out. When the price is more than 12, so that is the market demand then. If you multiply 100, because there are 100 people there. Right? Okay? Okay. Okay, let's graph it. What's the highest price anyone wants to pay in this market? 24. What's the highest quantity anyone wants to buy in this market? That's when the price is 0. You put 0 there, what do you get? 1500. That's 1500. These are two ends of the kink market demand. The kink is when the price is 12. When the price is 12, which is the intersection of these two lines, what do you get? You can put it in either of these two, you get the same number. This gave me 600, right? That will give me 600 too, right? This, the 12 is where these two lines intersect. So you should get the same number from both. I see this one is 600. That's 600 too, right? Is it? It's 600. Put 12 there, you'll get 600, right? Yes or no? Yes? So So we're fine. That's the verification. That is our market. Demand, which is king at 12. Because when the price goes above 12, A will leave the market. Make sense? Only B is in the market. Okay. Suppose the price is 6. What's the demand? If the price is 6, you're looking at which part of demand? This one. Right? So put 6 there, what do you get? If the price is 6, you're looking at this part of demand, this piece. What do you get if you put 6 there? 15 minus equal 5? No. How much? 4.5.
The overall answer is 104.
No, how much is this one?
105.
105?
So 1050.
Yes. Okay, what's the market surplus? So if you look at it, you can calculate that area, right? You can actually split in 3 and have the numbers. Definitely doable, but if you try it and you make a calculation error, you get nothing. You're doing geometry and you cannot even do geometry. That's the meaning of it, right? So it's better to say the market is nothing but consumers in it. Calculate the surplus for consumers, stack them up. That's more intuitive, less prone to error, and conceptual, right? So instead of trying to work on the graph, look at the individuals, see what happens then. So let's do it. So I'm going to use the individual approach. This is 12, that is 3. That is demand for A. I graph this one. When the price is 6, how much this guy demand? You put 6 there, what do you get? 1.5? 1.5. Am I right? That's 3 divided minus 1.5. That is 6. That is 1.5. So the surplus each consumer gets is 6 multiplied by 1.5 divided by 2, which is 4.5. Make sense? That is how much one consumer gets of group A, but there are 100 people there. So group A combined will get 450 in surplus. Right? Group A combined will get $450 in surplus. Right? 4.5 each, 100 people, 450. Right? Make sense? I'm fine. That's correct. Let's do the second one now. Let's do this, guys. Let's graph it. 24.12. The price is 6. How much they demand? You put 6 here, that's 9. 9. So each individual gets this in surplus. That is 18 multiplied by 9 divided by 2. How much is that? How much? 81. That's for one, but there are 100 people there. All combined get 8,100. Alright? So the market surplus becomes the sum of all surpluses. Which is this one. Alright? If you would have worked on the graph, you would have got exactly the same number. If you actually get this area, you will be equal to that. Yeah.
So we can use either method, right?
You can use either one, but if you try it on the graph and you get it wrong, you get nothing. Because you don't know what you're doing, right? If you do it this way, we know, if you know what the market surplus is, and you try to do it, you just may make a calculation. So I prefer the second one. Although that's what, historically people have tried most of them do it the way I did. Some of them have tried the graph. From those who tried the graph, I can say less than 50% got it right. For some reason, they make calculation error. And then you don't know what they're doing. Just numbers there. It's hard to say what they're doing, right? So you don't get partial points for it. Okay, anyway. Question for you. If this wasn't a test, how much is fair for it? How many points is fair for it? 100? One out of 1,000. You drive a Tesla, right? You don't? Okay. 100? Well, it can be 100 from a million, that's fine, but it's not from 100. How much? It's 10. The next version, not this version, the next version is slightly different. But it had 10 points. If you have practiced it, it shouldn't take more than 5-6 minutes, right? Do it right away. But if you haven't practiced it, you just go back and forth, and you run out of time. So the test is not very long. I know some people say it's long, have everything in it. It's not that long. Some people leave 1.5 an hour, right? Some people stick all the way till the end, they can't finish it. It all depends on how much you practice, right? If you practice, easily done, right? If you haven't practiced, you try to redo it. Think about it, and you run out of time, right? I had a student once on a midterm wrote the question as an answer for each question. That's not a joke. For every question, the answer was the question. I think they heard. Don't leave it blank. That's not what it means, right? You have to write stuff related to the question, right? It's not like repeating the question. Okay, I'll do one more, then we take a break, then we do more. This is the one that had 10 points. See that's 16. See how long will it take to do it? There are 400 consumers. Split equally between A and B. That's the inverse demand for A. That's the actual demand for A. And the reservation price for A is 20. Right? For B, that's the demand. That would be the actual demand. And the reservation price is how much? 40. Right? Make sense? So the market demand becomes 200 QA plus QB, which is 200. Sum them up. 40 minus this, if the price is low enough. Right? The price is low enough. If the price goes up from 20, then who leaves the market? See, the way the question here is like A always leaving the market. That's just a coincidence. It depends. The way I put them, the first one have a lower reservation price. It might be the other way around, so be careful with it. In this case, in all this question, it looks like the A leaves first. It's just a coincidence. Anyway, in this case, A leaves, that is the demand. That is 200. QB, that is 200. 20 minus P2. That is our market demand. And then you have to graph it. That is the market demand. That is this. What's the highest price in the market? 40. What's the highest quantity in this market? That's when the price is 0. That is 8,000. 8,000. Right? That's 8,000. That's the other end of the demand. And the kink is when the price is 20. 20 is on both these two lines, so you can try either of them, you should get the same number. This is probably easier. I get 2,000. There. You get 2,000 from this one? You should. Just verify it, make sure you don't have an error. 20 is a common point. So it should be, you should be able to get it from both. I get 2,000 here, do you get 2,000 there? Yes? Yes or no? If you don't get it, you're in an error. 40, yes, 2,000. That is 2,000. That is market demand, right? Kinked at 20. Again, if you don't have space there, that's 8,000. There's no space there to graph correctly, right? So you always get slopes that aren't in accordance. But they should be flatter than this one. That's the only requirement. Don't make it steeper. Don't make it like this. As long as you don't make it like that, that's fine, alright? The reason is, this is steeper than this one. See, that's 3/2, that's 1/2. This is steeper. That should be steeper, but that's the actual demand. You're graphing the inverse of it. Make sense? So when you have the demand steeper, the inverse demand becomes flat. You can see, if you flip this, if you actually flip this, it's steeper, right? This is steeper. But that's the way it goes. They actually start with the inverse, so it looks backward, everything. Anyway, next step. The price is 15. What's the demand? The price is 15. What is the demand? Give me the demand. You should use the first one, not the second one. That's where the price can be less than 20, which is 15. What do you get? If you put 15 there, what do you get? 22.5, 17.5, 1,500? 1,500? Oh, 3,500. That is this one, the price going up to 25. What's the demand? Now you should use the second one. That's 1,500, right? That will become 7 and that becomes 12.5. 7.5, 1,500, right? That is your. So the question says, find the change in the surplus when the price goes from 15 to 25. Graphically, the change in the surplus is this area. The question asks you to calculate that area. That's the change in the surplus, right? When the price goes up. Okay? Again, you can try to find that area. It's doable. You can split it in some parts. You can actually split it in 3 parts or 4 parts and solve it. You can solve it. But if you get it wrong, and most people get it wrong, you get nothing. All right? Do it the way I did it, which is find what happened to individual, stack them up. So I'm going to solve it individually. I'm going to graph this one, see what happened to a consumer there, then I go to second. Did I graph it right? Yes. The price is 15. The demand is 5. That's the surplus. When the price is 15. The surplus is this one. That's the surplus when the price is 15. The price goes to 25. What will be the surplus then? That's the surplus when the price is 15. Then the price goes to 25. What would be the surplus? How much? 0. You buy nothing. You get no surplus. That is the change in the surplus for one individual in group A. How much is that? That is for one individual. There are how many people there? 200. So altogether we lose $2,500. Make sense? The group A will lose $2,500 in surplus when the price goes up. Make sense? That's, yeah.
Where do you get this 0 minus 5 times 5 over 2?
Well, the price is 15, that's the surplus they get. The price goes to 25, they're gonna end up with nothing. Is the difference between the initial point and terminal point.
Okay.
That's the initial surplus, that's the terminal
So we're
surplus.
calculating not just the consumer surplus at 15, we're calculating.
We calculate the change. The question says when the price goes from 15 to 25, what's the change in the surplus?
Makes sense.
So it's the difference. That is for A. B, that is B. So I'm going to grab that one, and we'll do the same thing there. The price is 15. What is the demand there? If you put 15 there, what do you get? 12 and a half? 12 and a half. That's the demand, right? 15, 12 and a half. That is 12 and a half. That is the surplus when the price is 15, which is 25 multiplied by 12 and a half divided by 2. That's the starting point. That's when the price is 15. The price goes to 25. If you put 25 there, what do you get? 7.5. That is 15. Sorry, that's 25. That is 7.5. The surplus becomes this then. That's the surplus now. Which is 15 multiplied by 7.5 divided by 2. That's the surplus when the price is 15. That is when it was 25. That's a change in consumer surplus for B. How much is it? How much is this? Basically, graphically, we're finding this area. That's the change in the surplus. Right? We're calculating the pink area. That pink? What do I call it? This. We are getting this one. That's this one. We're subtracting from it this one, which is this one, and we're getting the pink area. How much is it? How much is the change in the surplus? Yeah. Anyone? Yeah.
Negative 100?
Minus 100. And you have 200 people there. Combined with those 20,000. The change in the market surplus is the sum of what all consumers combined will lose, which is 22,500. Now, this is more intuitive. If you make an error, just a calculation error. So that is preferred. If you do it on the graph, you get the same number. But if you get it wrong, you get nothing. Anyway, that is this. We're going to do another one after the break, but it takes 10 minutes to do it because I really slowed down. If you actually solve it within your own time, it should not be more than 6-7 minutes. Have 10 points to on the test.
I have a question about the triangle calculations you did. You did 15 times 7.5. Isn't the base 12.5?
This is this multiplied by this.
Right?
That is 15. That is 7.5. I'm trying to find a triangle, right? Height, length divided by 2. That for everyone, right? Make sense? We'll do another one after the break, but let's take a break.